Okay, so question number 32. Okay, it says they have a circular conical reservoir, vertex down, a depth of 20 feet, and the radius at the top is 10 feet. So it's going to look like this. I've got a conical reservoir upside down like this. It's got a height of 20 feet, so h equals 20, and the radius here equals 10. Okay, so this is, being a cone, I can see that anywhere the water height is, I know I'm going to end up with a similar triangle where the radius of that circle here is going to be half the height of the cone here. So it's always going to stay in the ratio of 1 to 2. So the water is leaking out so that the surface is falling at a rate of 1/2 feet per minute. So dH by dt is equal to 1/2 feet per minute. Right? So I need to connect the height to the volume, okay? Because we need to solve for dV by dt. That's our unknown. That's what we need to generate. We need to generate dV by dt, and we need to generate a dH by dt connected to dV by dt. So the formula for my volume of a cone is going to be pi r squared times h divided by 3. There's my volume of a cone. Okay. And I also know that there's too many variables in here because I've got radius, height, volume. So I need to, there's a few different things I could do here. I can just use the radius here, but I really should kind of simplify my variables, and I should really make sure that I understand this relation. The height is equal to 2 times r. Okay, well, I can substitute for r. Okay, so h over 2 equals r, and then I can square that, and I end up with an expression for with volume and height. Well, that's exactly what I want to be able to generate the parts I need. Okay, or I could actually replace the height with 2r, and I could do this. I could figure out dr by dt by just differentiating this by saying dh by dt is equal to 2 dr by dt. Okay, so if the height goes down by 1/2, okay, the radius I'm going to divide by 2. The dr by dt is going down by 1/4 foot per minute. Okay, we could do that, and we can use dr instead of h. Okay, so that's an option. I'm just going to do it, keep the h, because I think most people would want to use the h since the h is given in the problem. So I'm going to do this. I'm going to get rid of the r by saying h over 2, and I'm going to substitute. So there's my equation, 1/3 pi h over 2 squared times h. And I can simplify that. I've got connected my v to my h variable. I can differentiate this with respect to time and figure out all the parts of this. So dv by dt is what I'm looking for. Okay. I should have simplified. Maybe I'll simplify this first before I differentiate this. V equals, that's going to be pi over 12 h cubed. So dv by dt, I need a little bit more room here, is equal to 3 times 3, so I get pi over 4 h squared times dh by dt. Okay. The question, I just realized I need h, and the question gives me h. It says that the reservoir is 8 feet deep. So now I have all the parts I need. I have h, I have dh by dt up here, so I'm just going to plug that in. So dv by dt is equal to pi over 4. The height is 8, so 8 squared, times the derivative dh by dt. There it is, 1/2. And then simplifying that expression out, I'm going to end up with 64 over 8, so 8 pi cubic feet per minute. Okay, and I think that answer is B. Okay, so the answer for this one ends up being B.